Okay, so cosecant is defined as the reciprocal of sine. So I know that wherever sine is 0, cosecant will be dividing by 0, so have a vertical asymptote. So first, just like sine, cosecant has a basic period of 2 pi, but then here the b value is 4. So 2 pi over 4 reduces to pi over 2. Midline shift, -2. Phase shift, none. Amplitude 3. Okay. So again, since sine has a general shape like this, I know that its reciprocal cosecant will have vertical asymptotes at the beginning, middle, and end of the period. So because there's no phase shift, the beginning of the period is still at 0. Okay, and then the end of the period is pi over 2 units after 0. So 0 plus pi over 2 is pi over 2. And then halfway between these is pi over 4. Okay, and then I've got a midline shift of -2. And the amplitude tells me the vertices are 3 units above and below the midline. So 3 units above -2 is +1. And then 3 units below -2 is -5. And that occurs halfway between pi over 4 and pi over 2. Okay, so let's see, pi over 4 plus pi over 2, use the midpoint formula. Okay, so 3 pi over 4 divided by 2 becomes 3 pi over 8. And halfway between 0 and pi over 4 is pi over 8. Okay, next secant is defined as the reciprocal of cosine, but first I need to factor out the b value. Okay, so now I can see midline shift of 1, phase shift, plus pi over 2, it's x minus h, so x minus -pi over 2. Amplitude is invisible 1. Oh, I forgot to go back and do domain and range. So back on problem 4, the range, I can see I go from -infinity to 5. -5, excuse me. Then I skip until +1 and go to +infinity. And the domain, I can do all real numbers except for the asymptotes, which occur at 0, pi over 4, pi over 2. So every pi over 4 units, I get another vertical asymptote. So pi over 4 times n means all multiples of pi over 4. Okay, back to problem 5. So period, so secant, just like cosine, the basic period is 2 pi, but then you divide it by b, which in this case is 2, so the period is just pi. Okay, so I know cosine normally looks like this, with starting at the maximum and hitting the zeros at 1/4 and 3/4 of the way through the period. So these would be where the secant's vertical asymptotes would be. Okay, but I'll just focus on the starting point, which is the maximum. Okay, so normally the maximum occurs at 0, x equals 0, but because there's a phase shift, I'm going to shift it pi over 2 units in the negative direction, so to the left. Okay, so Let me do my midline shift next at +1. Okay, so the amplitude is 1, so from the midline I go up 1 additional unit to hit this maximum. Okay, so I can do the vertical asymptotes next. Okay, so the period is in this case pi, and I know that 1/4 of the period is to the left of the upwards opening vertex. So 1/4 of pi is pi/4. So pi/4 units to the left of this is -3 pi/4. Okay, and then once I have that identified, I take this, if I consider this to be the start of my period, pi units to the right of that, -3 pi/4 plus pi is 1 pi/4. Okay, and then I know that another vertical asymptote occurs halfway between these. So halfway between -3 pi/4 and pi/4 is -pi/4. Okay, and then the downwards opening vertex occurs 1 unit below the midline. So 1 unit below 1 is 0, and halfway between -pi/4 and +pi/4 is 0 as well. Okay, and lastly we have cotangent. Oh, let me do domain and range. So range, -infinity all the way to 0. And then start again at 2 all the way up to +infinity. And then domain, so starting at -3 pi/4, there's a vertical asymptote, then another pi/2 units later, and another pi/2 units after that. So all real numbers except, and I'll just pick this as my starting asymptote that's not allowed, -3 pi/4 plus, and again the distance between asymptotes is pi/2, so pi/2 times n. Okay, so now cotangent. So we've got a midline shift of -1, phase shift, so x minus h, this time the phase shift is positive, amplitude of 2, period. So I know cotangent's basic period is pi, just like tangent. So in this case, pi/1 is still pi. Okay, so I want to think about what the basic cotangent graph looks like. So I know cotangent is defined as 1/tangent, or I can think of it as cosine divided by sine. So wherever sine was 0, cotangent will be dividing by 0, so undefined. So sine, again, looks like this. So for the basic cotangent graph, it would have vertical asymptotes where sine was 0, which is at 0, pi, and 2 pi. Okay, so we're going to shift these all to the left. So the 0 at 0 will now be at -pi. The 0 at pi will now be at 0, and the 0 at 2 pi will now be at pi. So actually the vertical asymptotes don't change. They all get shifted over to the one on the left, or on the right technically, but it doesn't make a difference. Okay, so that means I know that there's vertical asymptotes at 0, x equals 0. Okay, I also know that at the end of the period, there is another vertical asymptote. Okay, let's do our midline of -1. Okay, so I know that the midline point occurs halfway between the vertical asymptotes. So halfway between 0 and pi is pi over 2. And midline. So then halfway between the left vertical asymptote and the midline point, I know cotangent looks like this. So halfway between those is pi over 4. And then the amplitude or the vertical stretch of 2 tells me go up 2 units from the midline. So from -1 up 2 units is +1. And then the amplitude also tells me in the other direction. So halfway between pi over 2 and pi is 3 pi over 4. So halfway between those is the x-coordinate, and the y-coordinate is 2 units below -1, the midline, so -3.